So like I say, good morning and welcome to our Tech20 series, our social showcase for speakers presenting technology-focused topics in 20 minutes. We're delighted to have you all join us on the webinar today. So before we kick off the presentation, there's just a few housekeeping points. We call these events Tech20 because we split them into 20-minute blocks. We have 20 minutes to hear from our speaker today, then 20 minutes for questions and answers, and finally 20 minutes for networking for anybody that can stay behind. We have two options for the question and answers. If you can use the QA function on Zoom, or if you raise your virtual hand, we can unmute you and let you ask your question. We want to make the session as engaging as possible for both you and the speaker, so please do raise your hand if you're feeling comfortable speaking. And again, it's that old, I guess, adage. There's no such thing as a daft question. If you're thinking it, somebody else probably is. So just ask away. We'll try our best to get through as many questions as possible during the 20 minutes. And if you would like to leave comments on socials, that'd be very much appreciated. And if you use the hashtag Tech20 and hashtag Time2Tech20. So let me introduce, I should say actually, for those of you that don't know me, I'm Keith Hogg. I'm the Emissions Reduction Project Manager here at Net Zero Technology Centre. And I'm just going to introduce our speaker now, Jim Gordon, who's a Business Development Manager for WellSentinel. Jim, can you tell us a little bit about yourself and what you're going to talk about today?
Absolutely, Keith. So I'm the Business Development Manager here at Sentinel Subsea. I've been here for 4 years. So I'll give a little background to myself at the start of this presentation. Today, I'm going to be talking about how we can utilize our well monitoring technology, WellSentinel, to effectively manage and monitor the integrity of subsea wells and showcase to the wider industry environmental stewardship is a key part of everything we do. Perfect.
Well, no, I'm really looking forward to hearing about that, Jim. So if you're ready, we can just start your 20 minutes now, and yeah, I'll hand over to you.
Brilliant. Thank you, Keith. So when I entered the oil and gas industry from university back in 2018, 4 years ago, these were the main topics of conversation that were happening at that time. These were the key challenges facing the industry. A lot of my peers went to other industries, and then the topics of conversation were quite different. But these here were the main challenges that we were really facing. I still don't fully understand a lot of the abbreviations, but the key focus at that time in 2018 was really around a reduction in cost. And also around maximising the efficiency of the subsea assets that we already had in the UK. Now, fast forwarding to today, 4 years on, in 2022, and although those points are still absolutely vital, another topic has been brought absolutely front and centre of everything we do. Whilst always being important, environmental focus has really taken a major role in the daily operations of operators, service companies, everyone involved in our industry. And I think it's really, really important that we're able to showcase that to the wider stakeholders. Operators, of course, are highly aware of their responsibility and accountability for safeguarding the environment. Environmental, social, governance, ESG, priorities are being talked about in boardrooms, not just to energy companies, but across the entire business landscape. Now, however, the only key difference is that most companies do not have to operate highly complex equipment in the harsh and incredibly remote environment of subsea. Ultimately, every well has a risk profile, and managing that risk is of the absolute utmost importance in safeguarding the environment. Unlike other assets, going to a subsea well is a much more labour-intensive process, often involving vessels, ROVs, planning, people. And the North Sea, the UKCS, has a lot of subsea wells. According to the NSTA, there are over 851 subsea wells contained within our continental shelf, all of which will have to be decommissioned at some point in the future. And each of those wells, as I said before, has a specific risk profile. The landscape of the mature and aging UKCS poses specific risks around weakened wellheads, valves, and Christmas trees, all of which need to be managed effectively for environmental peace of mind. And also contained within the shelf, we also have a number of suspended open water exploration and appraisal wells. These are wells that have been drilled and are not connected to any infrastructure, are not connected to any surveillance equipment or surveillance systems. And monitoring these wells, monitoring the integrity of these wells is a highly difficult and quite a hard task to do. Finally, just to give a little bit more background, according to the NSTA, the number of suspended wells is expected to double over the next 5 years. And that's really as fields reach the end of their productive life cycle and wells are put and suspended before a rig or a light well intervention vessel has the opportunity to go and fully abandon those wells. So you can see that the UK really has a large well stock of subsea wells, and it's really important that we manage those subsea wells effectively. Just to give a little bit more on the challenge that the industry is facing, if we take those 850 subsea wells and we give a 20-day of rig time to P&A every single one of these wells, well, that means that in order for all the wells in the UK to be decommissioned fully, it's going to take 50 years of rig time. Now, that doesn't include traveling to location, mobilization. That is just 50 years of one rig only doing P&A. So you can really see the challenge that the industry has here as multiple wells come up for suspension, and we really need to be able to make sure that time between COP or the end of production and full abandonment, those wells are managed effectively and safely, and also with the environment in mind. So talking about subsea well monitoring at the moment, as I mentioned earlier, unlike platform wells, going out and going to a subsea well is a much more involved process. The remote location of subsea wells often means, as I said, mobilizing a vessel, sailing out to the location and carrying out the work on the well, or inspecting the well, or checking the equipment's condition. And also during that time, that is also a snapshot of the integrity and the condition of that asset. The only moment you're able to really know what's going on is when the vessel is on location and the ROV is there. So really it's a snapshot of its integrity at that moment in time. And the other way of monitoring wells is by powered systems, either in well or external to the well. As we all know, in well equipment means bringing out some sort of intervention vessel. Again, highly expensive process to be able to install that. And there's also the issue of data. So does that data get installed into the infrastructure that's already there and brought back to shore, or does that data need to be gathered by another vessel, maybe doing other work to be able to go collect that data? So you can see that's a major challenge with some of the technology that we have at the moment. Also, a lot of that equipment to be able to monitor requires a lot of battery, a lot of electronics, a lot of active systems. Again, that means that time associated with that means you might have to go and replace that system. And ultimately, another way of monitoring these subsea assets is through the likes of sonar. Again, these have the same challenges that we see with anything that's being placed into the subsea environment. Data communication is a challenge. Battery life is a challenge. Getting that data back to shore is a real challenge for some of these remote subsea assets. So what we have spent the last 4 years here at Sentinel Subsea is developing a passive monitoring technology that removes the need for active subsea power and also for the need for data communication. So really what we've done at Sentinel is, as a key philosophy for what we do, is to remove the complexity from monitoring subsea assets. So what is WellSentinel? Well, I think it's easiest to explain it in 3 key and simple steps. So the first key step that we need to do is gather. So we have a range of gathering systems that are designed to direct and capture any fluid that may emanate in the subsea environment. And it is then these monitoring and gathering systems direct that fluid into what we call the monitoring module, and this is where the passive monitoring technology is held. And this is the critical part here. And you'll see this video here I'm about to show you is one of our 1,000-litre test tanks that we have here at the Sentinel office. And we're actually testing the detection of the material that may have emanated from the subsea asset. And we're also testing the beacon release. So in that monitoring module is an alert beacon. So you'll see there it goes. So it's detected a material and it's launched an alert beacon to surface. Now that alert beacon is coded to that particular well, in this instance, that we've put that beacon onto. It then communicates via Iridium satellite and alerts that well owner that that material has been detected in the subsea environment and that there may be an issue with that well and that they need to go and have a look. So how does it detect? So we call them triggers. So this is how the system is completely passive. This is essentially a materials chemistry. So we're talking about a passive monitoring system where a material is degraded that then releases a beacon. We have a range of materials that we've been developing over the last 4 years. The first material we have there is a gas system. Now that would react to typical gas that you may find in dry gas wells. We also have developed an oil-based trigger, which will react to liquid and fluid hydrocarbons. We have a fluid tracer. Now this tracer can be sealed in the well during suspension, and if that then escapes from the well, that means that the system will detect, will degrade, and then will release the alert beacon to surface. We're also in the process of developing CO2 triggers. A major focus for the industry at the moment is carbon capture, and we're able to develop triggers which can assist in monitoring carbon capture sites and carbon capture assets. We're able to mix triggers, so you may have an oil well with a gas cap, so we can put a gas and an oil trigger in the system. And finally, we're able to custom engineer triggers. We've had a lot of interest around other fluids and other materials that we're able to engineer systems for. But ultimately, all of these triggers, whether it's gas, oil, only reacts to the material that we want it to react to, and absolutely nothing else that it will encounter in the subsea environment. Absolutely nothing else. And that is the key to the materials chemistry, and the solution that we have here is that we have triggers that will react to one material and nothing else in the subsea environment. Once it's reacted to that material, it then releases the alert beacon to surface, indicating that that material has been detected, and you may need to have a look. So I'm going to show you a quick video. This is one of our coral gathering systems, or WellSentinel coral systems. It's been installed onto a 30-inch conductor. However, we have the ability to fit any wellhead profile, whether that's 36-inch, 32-inch, 18 3/4, 16 3/4, 13 5/8. So it's a highly flexible system. This gathering system here has been inserted with gas triggers. So if the well, in this instance, were to emanate gas, as you can see here, it's then captured into the top aperture of the system. There it detects, and the bar is degraded, And then the alert beacon is released to surface, as you can see, where it then interacts with the original satellite network and alerts the well owner that their well may have an integrity issue. Because the passive monitoring equipment is common across any system that we create, we're able to custom and we're able to fit our systems onto any point in the well's life cycle. So you see in the top there, we have a system that will fit over a wellhead protection structure. Now that's very common in the UKCS. Again, all we need to be able to do is capture and direct any escaped fluid into that passive monitoring equipment where it's then detected. Again, being able to fit onto any asset is really a case of mechanical design, mechanical engineering, and obviously the chemistry that's the core to this solution. You'll see the two at the front there, those are what we call the FROMs. Those are non-contact systems, gathering systems, where should there be no space on the canopy of the asset, or those work by gathering fluid as it drifts on subsea currents. So as you can see, our system has an incredible amount of flexibility to be able to fit a variety of subsea wells and again, monitor those subsea wells for environmental peace of mind and absolutely. So we actually deployed one of these systems in June 2021 last year. We're in collaboration with the NZTC and a North Sea operator. We deployed one of our WellSentinel Coral solutions, the one that you saw earlier, onto a live subsea well in the southern North Sea. You'll actually see the well there. That's it with all the coral on it. The well had been suspended for over 5 years with a suspension, plugs, a mudline hanger system, and a 30-inch debris cap. The well was at a depth of 30 meters, and the operator had asked for our solution to be deployed as part of a routine visual visual inspection campaign. The deployment was to be integrated with the routine IRM campaign, as I said, and we deployed it from the Deep Vision, which is a specialized ROV and survey vessel, which is designed obviously for going out and inspecting these wells. So the equipment was successfully deployed onto the well. During the operation, there was actually, surprisingly, evidence of gas at the wellhead. The operation carried on. The system was successfully deployed onto the well. Subsequently, the system reacted to the gas that was observed at the wellhead, and it operated as designed. The gas triggers, we know, degraded. The beacon was then released to surface, and the alert was received through our well monitoring portal within 1 hour of the beacon being released. Again, this is an absolutely massive step for us. I mean, it really does show the system being proven, deployed from a service vessel, proven and operational in a subsea environment. So you can really see, again, the technology and its growth from chemistry into an actual real-life system that we've deployed on a subsea well. So again, as I said, the beacon surfaced. That's it being tracked across the North Sea. The beacons are not deemed a fishing hazard, but they are recoverable should the well owner wish to recover. We tracked that beacon and it ended up in Denmark. I actually have it right here. I don't know if anyone can see me, but the beacon is here. This one was floating about in the North Sea, and it was gathered and collected and brought back to our workshop here. So again, this is the kind of interface that we would be able to supply to any operator. So I guess ultimately, what's the environmental benefit of a system like this compared with ROV flybys or other types of systems? Well, ultimately, what we provide is an early alert. We're giving the industry the ability to monitor and react to any subsea integrity issue that may arise. That tool is able to show stakeholders that well is being completely monitored for environmental peace of mind, and should anything happen, the operator can react and can mitigate any environmental issues. And also, by lowering the risk profile of that well, rather than needing to go out with ROVs frequently, we're able to take some of those vessel time away, and we're able to reduce the frequency and the need for ROV flybys. We recently did a validation report through the impact forecast, and this was actually for wells in the UKCS, and it showed that one WellSentinel system deployed on a well is able to save over a 10-year period over 400 tons of CO2, which in the report it gives it as the mass of 80 elephants, which I think is really cool. And it's also the CO2 absorbed by 18,145 trees. So you can really see the environmental benefit in two phases here: the ability to react and manage subsea emissions, the ability to cut down on the need for diesel-heavy vessels constantly going out and inspecting subsea assets. That is everything from me today. So again, I hope everyone here can see the benefit of having a passive monitoring system, both for the environment and for the industry as well. So thank you, Keith.
Perfect. Well, thank you very much for that, Jim. That was a really interesting presentation. Just to the audience, is there any questions for Jim? I can't see any in the chat, but if you have any questions, if you just want to raise your hand. Oh, I can see Charles Bain raised his hand there. So if we could maybe unmute Charles and just go ahead and ask your question.
There you go. Can you hear me okay?
Yeah, I can hear you fine.
Yeah,
there,
magic. No, well, first of all, Jim, that was a really great presentation. It was, I mean, I've been following you guys a while, but I've got a very visual brain, so it's great to see it all, put together and exactly what you guys are doing. I guess my question is, I mean, I come from a wellbore abandonment and cleanup background. I'm now an ROV operator. Is how much do you look to reduce these? So you say it's a biannual inspection generally in the current wells. What are you looking to reduce that by? Is it going to be down to an annual? Is it a 5-year? How integral is your equipment? How often does it need to be inspected?
So we've qualified the equipment for two long-term periods. So we've got a 10-year system which we can deploy. We've also got a long-term system for 25 years continuous deployment. We've spoken with a number of operators who feel comfortable shifting inspection by again 5 to 10 years. Moving that frequency of that inspection from biannually or annually out, and any of that again just reduces cost and reduces the CO2 taken up by using those vessels to inspect subsea wells.
I mean, even as an operator of these wells or someone that's looking to decommission, for us as bystanders, the environmental benefit's incredible, but that as a cost saving is huge. I mean, vessel time downtime and ROV downtime. So no, that's amazing.
Thank you, Charlie.
Perfect. Thanks for that, Charles. That was a really great question. There's another hand up there from Elliot Ewan. Elliot, if you want to just unmute yourself and go ahead and ask your question.
Hey guys, I'm Elliot. I was just wondering, Jim, are there any depth limitations to this?
So we have actually, again, through the NZTC, we have tested this hyperbarically. We've blown the triggers down to a depth of 3,000 meters. So that is way in excess of anything you're going to find in the North Sea. This system responded perfectly. So we're able, again, to qualify the system for deep sea use. So there really is not really a depth limitation. The beacons themselves are qualified for deep water as well. We get those from a supplier in Canada who supplies these globally for scientific use. And this is the first time that they've applied this in an oil and gas context. But again, those are normally used for deep water and actually some of them in the Marianas Trench. So again, we have qualified the system for very deep water, and there really shouldn't be any issues for depth.
Great, thanks very much.
Brilliant. Thank you, Jim and Elliot. So, any other questions for Jim? Charles, I can see your hand's still up. I don't know if you have another question, or maybe, oh, that's it. That's it. Just a quick question, actually. Well, an observation and a quick question for myself, Jim. So I think, and to tie on to what Charles said there, I think a system like this, obviously the benefits talk for themselves. Periodic inspections are great, but like you had mentioned in your presentation, that's a snapshot in time. It's not really giving you a full picture. And wells, I guess, unless they have quite significant integrity issues, don't tend to consistently flow. It takes a while for that pressure to build up and then release. So that's really where I can see a system like this really kind of giving you that overview that you need to alert you to any integrity problems. So going forward, when we're looking at our reservoirs and we're looking at things like reservoir reuse, for instance, CCUS, and the different pressure and temperature challenges that may bring to pre-abandoned wells that may be within reservoirs that we look to reuse. Do you see that as a significant portion of the deployment of Sentinel going forward, for instance, CO2 storage?
Absolutely. I think ensuring that when reservoirs are repressurized, that wells maintain their integrity, wells that were previously abandoned, not to take that pressure, not to take that CO2. I think placing systems like this over wells like that just gives another level of assurity to operators, stakeholders involved, that the wells are being monitored, and ensures that should anything happen, a release of CO2 it is detected. And I think that's really important, being able to showcase that everything is being done to mitigate those risks that are involved with carbon capture, I think is a major part of where we're going. And that's why we're working with operators in developing and looking for information around CO2, because we need some more data in terms of what comes out first. Is it the CO2? Is when the reservoir is repressurized? Is it the gas or is it the oil? So we are really looking into that, and I do see that as a major market for us in the future. And again, I think the system's so simple. It's such an easy solution. There's only one change that really needs to be made, and it's the triggers in that system. The rest of it would remain the same. So again, it's a highly flexible system that can be fitted across a wide range of applications, Keith, and I think CCS is definitely one of those.
Yeah. No, brilliant. Yeah, and I think it really talks to what we need to, reputationally wise, like you mentioned as well, as an industry. Technologies like WellSentinel really talk to, I guess, our social environmental responsibilities, and it's a global problem, right? I mean, in terms of, I guess, what our P&A liabilities are in the North Sea. Yeah, we have a lot of wells, and we have, I guess, a bow wave of work coming up. But globally, it's the same story. And with resources, ultimately, we're going to have to suspend some of these wells in excess of the time period of what we'd like. So I think it's hugely important that we have good monitoring in place when we're faced with that. that situation. So any other questions for Jim there? Because I'm conscious I like to talk and I'll probably just use up all the time asking one questions otherwise. So I don't see any other hands, so I'm going to ask another question, Jim.
Sure, no problem, Keith.
So one thing that I'm interested in as well is, so I guess when we in the UKCS and other basins across the globe, when we first started producing hydrocarbons, there was never, probably because the technology didn't exist at the time, there was never any baseline readings taken around what gas content was at seabed. So I guess one of the arguments that we hear quite often is, well, how are we going to differentiate between thermogenic and biogenic gas? Because obviously biogenic gas being a natural phenomena through degrading of organic materials. So how do you guys do that and ensure that you're not getting false alerts from what is naturally biogenic gas at seabed?
Sure, absolutely, Keith. So we've developed what we call a fluid diverter system. Now what that will do is it will divert away that biogenic gas from the system itself. So we can set that to a certain level, and only when that level is in excess of what we would call that baseline, that biogenic gas, it would then divert into the reaction chamber. Now that is under IP at the moment, so I can't go into too much detail, but that is one of the ways that we're able to mitigate, and that's something we've encountered a lot when speaking with the industry, as well as the concern for false alarms due to biogenic, and it's something that we have multiple different mitigating subsystems in the unit to be able to make sure that that false alarm is not isn't something that happens. Also with the triggers are not a hair trigger either. So the triggers are developed to be able to sound a certain level of background gas background gas, and will only react again if there's a certain level of increase in that background level of gas.
Perfect. No, I think that's really it's really good to hear, Jim, because it is something that we hear quite often. Anybody that's involved in well P&A and well integrity and the potential for wells to lose integrity and leak, it's one of the things that we hear quite often. Well, how are we differentiating between biogenic and thermogenic? So that's really good to hear. Any final questions for Jim? If you just want to stick your hand up or shout out. But if there's none, then I would like to really thank you, Jim, for taking the time today to present. It was a really interesting presentation, and I'm sure that going forward, WellSentinel is going to be hugely successful globally. If anybody would like to hang back and just do a little bit of networking, a more informal chat, then feel free to do so. Sophie, who's controlling the Zoom here, she can promote you to a presenter slot, and you can just hang back and we can just have an online offline chat. Sorry. So, but if that's it, I would just like to thank everybody that attended today for attending. And for your participation and questions. Like we say, we like to make these things as interactive as possible. It makes it more interesting for everybody. So again, thank you, and I hope everybody has a great weekend.
Thank you, Keith.
Excellent.